Welcome to the lesson Motion and Speed. In this lesson, you'll learn the science concepts behind motion and speed. The vocabulary words for this lesson are motion, speed, position, reference point, velocity, and vector. These cars raced to the finish. It took both cars 10 seconds to drive their tracks. Which car was traveling faster? Let's find out which one traveled with more speed. The time it takes each car to finish only tells part of the story. Look at the tracks. One car had to cover a lot more ground in those 10 seconds. Speed is more than just the amount of time it takes to get somewhere. Let's define some words before we talk about speed. Click on the pictures to explore the topic further. A position is a place. Here, the red car looks like it is in first place. Its position is at the front of the other cars. If an object's position changes, we can say it is in motion. If we want to measure motion or speed, we need to have a reference point. This means we must have a place on which we can compare the moving object. The finish line is a great reference point. We can see the cars past the finish line, so we can be sure that the car moved past that point. If we see that an object is in motion, we can measure its speed, or how fast the object moves. To know an object's speed, we must first know the distance it has traveled and the time it took to travel that distance. We calculate speed by dividing distance by time. If you watch the train, it has many different speeds. However, it will only have one average speed. Move the timeline to the 5-second mark. How far did the train travel? 5 meters. Now use the speed formula. 5 meters divided by 5 seconds is 1 meter per second. Move the timeline to the 10-second mark. In 5 seconds, we see that the train traveled 15 meters. That's 20 minus the 5 it already traveled. It's 5 seconds later than the last time. So 15 meters divided by 5 seconds, 3 meters per second. That's the train's speed. The train's speed changed. Now, move the timeline to the 15-second mark. The train moves from 20 meters to 60 meters. The train traveled 40 meters in those last 5 seconds. Again, divide the distance by the time. 40 meters divided by 5 seconds is 8 meters per second. That's 3 different measures and 3 different speeds. Now move the timeline to the total mark. You might hear people use the words speed and velocity as if they are the same. In science, these words have different meanings. Click each word to learn the difference. Speed is distance divided by time. Look at the trains. We can measure the distance the two trains traveled and the time they took. The two trains have the same speed. These two trains have the same speed, but they are not traveling in the same direction. What their speed calculation does not tell you is the direction in which they are traveling. The scientific term velocity includes both speed and direction. Velocity is a vector. A vector is a measurement that includes a direction. For the velocities of the trains to be equal, the trains would have to be going the same speed and in the same direction. You sometimes see speed represented on graphs like the one shown here. This is a distance time graph. You can see that the distance increases as the amount of time increases. Each graph matches the car of the same color. Let's imagine that the cars are at a stoplight, and then when the light turns green, cars will start moving. The graphs show how fast the cars can go after the light changes to green. You want to pick the fastest car, so pick the car with the greatest speed. That's correct. The blue car has the greatest speed after the light turns green. The graph shows you that it traveled more distance than the red and green cars in the same amount of time. What is the runner's average speed? The runner covered 400 meters in 80 seconds. His average speed would be 5 meters per second. Distance divided by time. This graph shows the speed of a car as it drives through town. Each speed on the right over to the correct segment of the graph. Well done! The first segment of the graph shows a speed of 1 meter per second. The second segment of the graph shows a speed of 0 meters per second because the distance did not change. The third segment shows a speed of 2 meters per second. The last segment shows a speed of 10 meters per second. These rats will race through their mazes. How can rat A reach the cheese at the same time as rat B? Type your answer in the box. Click OK when you are finished. You've learned a lot about motion and speed. Before we finish, Let's take a quick look at the main points you've covered. An object is in motion when it changes position. The speed of an object is equal to the distance traveled divided by the time it took to travel that distance. Velocity is speed with a specific direction. Now that you've finished the lesson, click the menu button to exit. Or if you wish, you can go back and review any part of the lesson again.